Good morning. My name is Ting Wei Yeh. I'm from Professor Dacker's research group. And today I'm going to talk about GaN nitride Nanorod arrays grown by selective area growth. And we expect this Nanorod array can be used for improving LED efficiency. Indian GaN nitride-based LED has been used for blue LED, and then it can be fabricated to produce white light. So it has many advantages for mobile devices. So for example, they have very high efficiency and compact size, and very long lifespan and non-toxic composition. But there's also some challenges for this material to be used for lighting applications. For example, they have fair light extraction efficiency because there's some refractive difference in refractive index between GaN nitride and air. So it causes Fresnel loss and total refraction loss. So light will be trapped inside the GaN nitride material. And the other thing, the second challenge is the efficiency drop with increasing injection current. This phenomenon is called efficiency droop. And nowadays, the origin of this efficiency drop is not very clear. So we expect if we can grow nanostructures which has high surface to volume ratio, then the current density will be decreased, and it might alleviate the problem. Also, GaN nitride and Indian GaN nitride multiple quantum well are used for the active region for the LED, and because of the lattice mismatch between these two materials, so there will be a strong piezoelectric field caused by the strain. So in some studies, people grow Indian GaN nitride on nonpolar substrate, and they can reduce or eliminate the piezoelectric field inside the active region. But the problem of the nonpolar substrate is the cost. So that is why we want to grow GaN nitride Nanorod as a potential solution to solve these challenges. Here's a diagram shows the GaN nitride Nanorods grown on GaN nitride block, and here's the enlarged image. So GaN nitride grown along 0001 direction, and the sidewalls shows the 11000 plane, which are nonpolar planes. So with increasing the nanowire, the length, or the height, and we can get more nonpolar surface. So if Indian GaN nitride and GaN nitride multiple quantum wells grown on these nonpolar planes, we can reduce or eliminate the piezoelectric field inside a quantum well. Also, this kind of nanostructure, the geometry of this nanorods can improve the light extraction from this structure. So there are some two main approaches to grow nanorods vertically. One is by VLS, which use metal platters to grow nanowire or nanorods, and the other one is selective area growth. Today I will focus on selective area growth. So generally, GaN nitride grow on a specific oriented stripe and control the growth condition. For example, in this case, they change the growth pressure and growth temperature to adjust the the sidewall angles. But if the pattern is not oriented along some specific orientation, just like we want to grow Nanorod on the holes, and it usually will result in pyramids. So because of the slow growth rate of the 1,501 planes, so usually the pyramids are formed. And so in University of New Mexico, they try to use pulse growth to grow vertical gallium nitride. They use laser interferometric lithography to prepare the mask, and then they introduce a trimetal gallium and ammonia alternatively into the reactor. Trimetal gallium is the gallium source, and ammonia is the nitrogen source. And here's an example of their gas flow rate and the period. Then I will talk about how we prepare our mask. Here's the procedure. We grow gallium nitride dope or silicon dope, but on sulfide substrate in MOCVD. And then a dielectric mask is deposited onto the gallium nitride block by using PECVD. And the dark array pattern are prepared by heaping lithography, and the pattern is transferred to dielectric mask by dry etching. And then the mask is ready for gallium nitride nanorods growth. So then I will show our result of the so it's not very clear here. Actually, there's some it's a vertical gallium nitride nanorods grown on gallium nitride block, and they show 6 vertical sidewalls. And this is the inset of the nanorods taken from the top view. And from the orientation of the gallium nitride substrate, these planes are 11500 planes, which are non-polar planes. And here's the nanorod we grow in a larger area. So we use TEM to analyze the crystal structure of these nanorods. Sorry, the image is too dark. So this image shows the lower magnification of the nanorod, and here's the in the image it shows this what size crystal structure, and I have a higher magnification here, so it's very dark. But from the spacing of the fringes, it indicates this crystal is world side, and also from the diffraction pattern. And this image are taken at 1, 1, 2, 0 zone axis, and then this wire is taken at 1, 1, 0, zone axis. And it also shows this is a wall-side crystal structure, and from the high magnification, lattice fringe, and diffraction pattern. And in both images, we did not observe any staking fold inside the nanowire or nanorod. So this rod might provide a put a better electron transport along the wire. Here's the conclusion of my talk. All the GaN nanorods are successfully grown by selective area growth. And the exposed vertical sidewalls are non-polar planes, and which can be used as a growth template for Indian GaN nitride microquantum wells. And also, the water-type crystal structure was confirmed by high-resolution TEM, and both zone axes 11500 and 11250. There's no stacking code. And these Nanorod array are candidates for enhancing light emitting diode efficiency. Thank you.
There's time for questions.
In the SEM image you showed, it looked as though the nanowires had some kind of different tip material. If you show the SEM image, it looks like there's a different phase of something on the ends of it. But if it's selective area growth, I don't understand what that is. Like gallium droplets or something?
Your question is...
What's the white tips on?
This white tip?
Yeah.
Oh, because you can see there's some wire that looks wider. So that can be because of the pattern preparation. If the hole size is different, they affect the growth result. Also, the growth condition also affect the wire, this Nanorod growth. And this white indicate it actually is from the top. So usually the secondary electrons are more easy can be detected from the top edges. So yeah, that's why it's white.
Any more questions? Well, let's thank Ting Wei one more time.